First thing I got to do in solving a system by graphing, I have to place them in y equals form so I can graph them in a useful form. All right, so right here, I need to have this in y equals. So I can essentially move everything to one side and the x and the 3 to the other. Y to one side, the x and 3 in the other. So right here, since I have a negative y, I'm just going to add y to each side. And I have now x equals y plus 3. And that's still not in slope-intercept form. I now have y as a positive, and I need to move that 3 over here so that I know what my y-intercept is. Subtract 3. I'll just keep going to the right. And I have, if I flip this, I have y equals x minus 3. I just switched the sides that they were on. Okay, then I got to do the same thing with this bottom equation. Since that's negative, I'm going to move it to the other side so it's positive. So I don't have to end up dividing by a negative there at the end. So now I have 7x equals y minus 3. And I need to get that y-intercept over here. Add 3 to each side. Once again, now on this left side, I have 7x plus 3. So first thing you got to do, get equations in y equals form. All right, second thing we got to do. Draw your x and your y-intercept, or your x and your y-axes. Use slope and y-intercept to graph. So for this top equation, I'll have to start where? A -3. And what's my slope there? What's the slope is x? This top equation, that's what I'm graphing right now. What is the slope? It's the number in front of x, so it'd be 1. So I go up 1 over 1.
What is that one say on
Get the equation in y equals form. All right, now for my top equation, here's what I have. I have 7x plus 3, so I have to go up 1, 2, and 3. All right, now, if I go up 7, 2, 4, 6, 7, and over 1, I'll be all the way up there, right? Is that where the solution is going to be?
No.
No, so I'm going to have to reverse my pattern. I'll have to go down 2, 4, 6, and 7, and to the left 1. Solving by graphing? No, you didn't. And all of a sudden I notice, hey, I didn't go far enough on this line, so I have to complete that line going backwards. And I have a solution where they intersect. So my solution right here is -1, -4. Read your solution from your graph. Now, if you do this in your calculator, you'd have to press second trace and then intersect.
So you basically, when we're taking this quiz, just plug in the equations.
Not if I tell you to do it by hand. If I tell you to do it by hand and I don't see work, you get 0 credit because you didn't demonstrate your knowledge of that concept. All right, now we also have solving systems by substitution. Come again?
Well, like it's really hard to see.
Yeah, well, I don't know why you do.
Like,
What?
It's really because we don't have the same stuff as you. Ours is like way darker. For the graphic.
Okay. So I have other graph paper over here, but right now, what I provided is what I provided.
Well, can we just like use it as like a notebook piece of paper?
I'm going to provide you with what I have right here during your summative.
Okay.
Okay. Solve systems by substitution. All right, so here's the example I'm going to use. 2x plus y equals 20. And 6x minus 5y equals 12. Okay, what's the first thing you got to do in solving by substitution? What's that? Does it have to be y?
No.
It could be x, but in this specific system, which variable would you prefer to solve for, Porter? Yep. So the first thing I got to do, solve for one variable. So in this top equation, 2x plus y equals 20, as Porter just said, subtract 2x from each side. And y would be 20 minus 2x. All right, so now what do I do? Porter? Yes. Plug that expression into the other equation. And solve. So here is the big step. If you don't understand this process, this is where you'll get lost, okay? So it's got to go in the other equation. So this represents y, so that goes into y on the other equation. So I have 6x minus 5 and now instead of y, I have that expression, 20 minus 2x. All right, now it says to solve. This is another big point of confusion where confusion can start is if you struggle with these algebra skills that you learned in Algebra 1, or in Math 1, sorry. Still used to teaching in a school that calls them Algebra 1, okay? So you ask yourself, is there anything I can do with the 6x yet? Nope, so move on. Okay, so now this -5. What do I have to do to everything in the parentheses? So I distribute. So -5 times 20 is -100. And -5 times -2 is positive 10x. Okay, so now what? Combine the x's. So 6x and 10x makes 16x. All right, what now? Add 100. So 16x equals 112. Divide by 16. And what's x end up giving you?
7.
That is correct. All right, the third thing we have to do. What do we have to do now? Plug the value you found in to find the other variable. All right, I'll move this up a little bit. And so I plug this in. Which equation should I plug it into?
Either one.
You should plug it into both.
I could plug it into both, but where is it going to give me the least amount of effort to give me y? Okay, I would agree this, but do you see how we solve for y over here? We can plug it back in right there, and all of a sudden, I don't have to do anything. It's just computation. So y equals 20 minus 2x. I brought that down from here. And I can just plug that right back in, 20 minus 2 times 7, and that'll give me 6. All right? Fourth thing you should always do, check your solution. How do I check my solution? Plug it back into the equations. All right, so now that top equation, 2, and the value I found for x was 7. All right, I plug it in for y. The value I found for y was 6. And I believe that 14 plus 6 is 20. And now I plug this in for x. I found 7 as the value for x. And 6 was my value for y. And we'll see if that equals 12. Well, I'm not great at multiplication, so I'm going to simplify this. 6 times 7 is 42. 5 times 6 is 30. And I think that 42 minus 30 is indeed 12. And those are your toolkit entries for solving by graphing and by substitution.